I'll do a quick introduction. Again, my name is John O'Brien. I'm a senior technical advisor within the cyber defense branch at CSE. My background is in malware analysis, primarily as a developer. I came out of school, was the one rookie in the room, and when somebody asked who's going to volunteer to do this reverse engineering thing, looked around, no one really volunteered, so I kind of put my hands up, and then I spent the next 6 years smashing my face against the wall, trying to learn how to do this stuff. Back in the day, it was actually hard. Right now, it's pretty cool. There's lots of tools. So if you're interested, we can talk about that offline.
Hi, my name is Garon. I'm the lead developer for AssemblyLine. You can see that my slide is in French, so if you have any questions in French and English, I can answer those questions in both language. So I've been working with John on malware analysis and to do incident response. And then 7 years ago, we decided that it was not working very well, so we started to develop AssemblyLine, and from then on, I've been working on that project.
The one thing I always kind of tell people is that don't ever hire developers as analysts, because then they just want to do development, and that's kind of what we did, and it seems to have worked for us. So, how do I start this? I try to describe who we are, and I never really do a very good job. So I thought I would start by describing who we aren't. It's just more fun. So last couple of weeks ago, we were in CBC, which is unheard of for anything to do with CSE. And my ADM at the time made the mistake of kind of throwing a little bit of sarcasm into his interview. And he used the word super secret spy agency, which obviously was quoted as the titles. So we are not the super secret spy agency. We are here in front of you talking. My picture is on the web now. We're kind of out. And the other kind of thing that I like to talk about that is the first rule of Fight Club, same as the first rule of CSE, is you don't talk about Fight Club and you don't talk about CSE. We seem to have failed at that, but we're okay with that. We're good. We're definitely not CSIS. And I wrote this slide, and I came back to it later, and I'm like, oh, that's kind of really awkward. It makes us look like we're kind of digging at CSIS, and we're not. Like, we like CSIS, they're great people. But if you're making the choice between going to work for them or working for us, come work for us. We're way better. Just totally way better. I noticed just the other day on Twitter, we get to use Twitter now, that our comms branch is actually kind of stealing our jokes now. So they actually went out and they commissioned a survey to find out whether or not Canadians knew who we were. And they don't. They don't know who we are at all. They all think we're CSIS. So I'm just going to keep repeating this fact. We're not CSIS. The other amusing thing about this is that the people that did know who we were didn't actually know that it was called Communication Security Establishment. It seems to be Canadian Security Establishment is the word of the day. So we're going to keep coming out here, keep talking, keep telling people, because at the end of the day, we actually do need to hire people, and it's tough when they all go to CSIS's website, not ours. So let's talk about who we actually are. We are the Government of Canada's lead cybersecurity agency. I've taken the text on here is actually the second part of our mandate, and this is part of the IT security branch, right? So our mandate is to essentially provide advice, guidance, and services to help ensure the protection of electronic information, of information infrastructures of importance to the Government of Canada. That's a mouthful. In reality, what that means is it's our job to help protect everyone in the government, as well as think about it as critical infrastructure, right? So these are very legal words and they're hard to define, but we want to help you. The other two mandates that I don't have listed on there are obviously our mandate to do foreign intelligence collection for, again, Government of Canada priorities, and to help provide technical assistance to law enforcement and military operations abroad. We're not going to talk about those because those get into more complicated issues, but we're good at talking about defense, so we're going to focus on that today. So this is a quote we found when we were going through, because we didn't really want to have any real words on the slides. This is from 2002, I think. It's Richard Clark, the White House cybersecurity advisor. It's a pretty harsh quote, right? If you spend more money on coffee than on your IT security, if you worry about whether to have decaf, or I don't drink coffee, so I probably should be talking about coffee, but that you deserve to be hacked, right? That's arguably true, right? If you focus on what kind of breakfast to feed your employees and you can't patch your systems, well, I'd like to feel bad for you, but I kind of don't. Yesterday, I asked everyone in the room if they all use two-factor authentication for their online activities. So did anyone actually go home last night and kind of enable two-factor authentication? Anyone? Hands? Anyone? No? So why not, right? I gave you some advice. I gave you explain why this would help you in your online world, people choose to not take advice and to not do security, right? So if the security practitioners in the room, in the community, can't do the bare minimum, right, by our own standards, how do we expect departments and businesses and small and medium, large businesses to be able to do the right thing, right? This is the struggle that CSE has, right? We're providing advice, which we think is pretty good. No one seems to want to follow it, so it's an odd place to be in. The speaker before me talked about essentially all the bad stuff that's going on in the world. It's pretty rough, right? We always want to focus, though, on the cyber aspect of things, right? But it's not that. It's going back to the olden days, right? Corporate espionage, theft, organized crime, right? Like, they just have the internet now, right? So if we approach the problem thinking about the actual core mission of the people that are attacking us, then we can start to kind of rationalize why they're doing this and what we can do to influence them rather than just worrying about the cybers, right? Everyone likes to talk about cybers, but we can change the game a little bit. So all that stuff aside, let's talk about AssemblyLine. So roughly 7 years ago, we were a small team, myself, Steve, and one other person, and we were doing all the malware analysis for essentially for all of CSE. We had a fairly large analyst team who were pretty good at actually finding things, right? So they would find things, they would throw it to us. Stats we have here, so on a given day we'd find about 10 bad things, 5 of which were unique, 5 of which are probably Internet Explorer, because back in the day it was browser helper objects and no one seemed to be able to tell the difference between the two. So depending on which one of us was in the building, was sick, or whatever, we'd get between 0 and 5 files done. That's kind of good, but really not the end of the world. So our kind of mission, our vision statement was we wanted to have consistent analysis and reporting for malware analysts, right? We're developers, we can solve our own problems. So we started automating, right? And everyone who's used the internet has probably seen this comic before. The idea being that you start writing some code, it takes a little time, you stop doing the real work, and then all of a sudden the automation kicks in, and then it's just great. You can sit there, look at cat videos all day, you don't really have to do anything anymore. In reality, you write some code, it doesn't work, you write some more code, it breaks. Finally it works, but then you just have this long tail of development. And I'd like to say that we kind of didn't fall into this trap, but we're still here talking about AssemblyLine. That's okay. The other kind of challenge with this is that when we built AssemblyLine, instead of actually making our jobs easier, we actually just found more malware, right? So, shit, we failed at that. So, obviously, any good development project, scope creep sets in. And again, we work for the government, so we are the experts of scope creep. So we took our little thing, which is like team of 3 people. We're just gonna, just make some consistent reporting, right? Everyone will be happy. And then we said, how about we just switch that? We're gonna detect and respond to all malware targeting the government of Canada. Just, whatever, right? We'll just do the internet. So we did. And this happened, right? 10 files to about 10 million files on a given day. I'd like to say that we have a cloud, but we don't, right? So we do what we can with what we have. And we did that a couple of times, and everything lit on fire, and then we did it again, and it lit on fire again, and then we did it again, and it worked. So 3rd time's the charm. So AssemblyLine, this very much saved us. When we started doing the development on this edition, these are kind of like the key messages that we basically needed to fix, right? So we knew that we needed to have a distributed platform. We weren't going to be able to do this on a single node. Because again, the internet is all cat videos, we needed to handle unbalanced workloads, right? So 1 million PDFs today, 1 million flash files tomorrow, whatever, all over the place. Again, since we run our own systems and everything breaks, we had to build a system that would be able to tolerate and recover from failures. And then again, it's the internet. We're kind of, right? We're processing. When I say the internet, I'm talking the internet as what the government of Canada sees, right? So traffic into the government of Canada, people's emails, that type of stuff. So that's all very repetitive, right? The internet is just cat videos nonstop. So we needed very aggressive deduplication. And then again, we have analysts and they know where we sit. So if we just send them all these alerts, tell them these things are bad and they're not bad, they will come and find us, and they're very persuasive about providing good alerts and good ways to deal with this mess. And then again, scalable, right? Like this, we assume we went from 10 to 10 million. I assume that we're going to go from 10 million further up, right? So this system needs to be able to grow past what we expected it to be able to do. So where are we right now? On any given day, we essentially will ingest about 10 million files for triaging purposes. After deduplication, we can get that down to about 2 million. And then based on those 2 million files, we're generating between 3,000 and 150,000 alerts. That's pretty good on the low end. If we send out 150,000 things, our analysts, they like to find us. So one of the challenges that we have with AssemblyLine is actually describing what it is, right? So I'm going to try going to the 10,000-foot view, and hopefully that works for you. So someone gives you a file, right? You're a malware guy. Someone gives you a file. What do? You take that file. You submit it either through our API or our UI. That file is then tasked to a bunch of different services, so things just kind of go flying around. Any services that process those files that find anything of interesting, they can extract something, they can send it back up, and that kind of keeps going through the queue. Everything becomes related. And then each service that's running, service, what we call an analytic or plugin, service, we'll just stick with that, has the ability to generate a score, generate tags, or generate results. And I don't think we talk about score very much, but if you want to ask the question of how we generate scores, it's more or less a pseudo-random number generator. So you think I'm joking, but I'm not. Not at all. It's all about the analyst, right? So malware is bad, right? This is kind of the disclosure I want to give you, is that when you deploy the system, you're dealing with malware, right? So I assume that everyone knows what that means, but I'll tell you if you don't. Segregate the system where you can. You only need HTTPS to get into it, SSH for admin. Some of the services will execute the malware if you allow them to, right? So you have to assume that the system itself is hostile, treated as such. We have the ability to run binaries within the services. We have the ability to run containers. We have the ability to run VMs. So depending on how much or how little you trust an individual service, you have the option of choosing where to put it. And then the one last thing I'll say is, again, because we run these things on our corporate systems, any file that's downloaded from the system, we actually wrap in this file format called cart. We used to use password-protected zips with infected, but all the AV people in the room, you've ruined that for us now, so we have a new thing. We don't talk about that in the talk today, but we can talk about that offline. It's actually pretty cool. So how does this actually plug in, right? So AssemblyLine, secure perimeter over there, don't trust it, pretend it's evil. Over here, right? So you have your analyst. You can do all of your manual submissions. That's great. But realistically, you're going to want to plug this into something, right? So we call this data sources because I don't know what your data sources are. If you have, a network collection, or you have AVs, anything that can give you a file, we consider that a source. If you want to plug this directly into your mail server and just have it act as a mail transfer agent, we don't offer that as a service, but you can build it pretty easily. On the other end, which I didn't draw, is kind of what happens after, right? So for us, we actually take alerts from this system. We use that to feed into our kind of dynamic defense systems that we use to protect the government of Canada. So we're actually blocking things in real time. We're racing people to the click. So core components of the system. There's actually way more lines that should be on this graph, but it becomes really confusing, so we just took half of them off. So don't treat this as gospel. The UI API essentially will throw things down to middleman. Middleman essentially is our ingestion processing. Its job is to throw things away. We don't want to process things if we've seen them before. We don't want to process things if they're whitelisted. We don't want to process things if there's any reason you can have. Middleman's the one that sets the priority. Once it's decided that we actually will scan this, it'll throw it into the dispatching layer. Dispatching layer's job is basically to make sure that things complete, right? So it's going to fire it out to service A, B, C, in whatever order you've specified. And its job is to either complete them or make sure they fail enough times that you don't really care, right? We assume things are going to fail, so we've designed for that. We've got Redis and RIAC as our kind of queuing and storage layers. Won't go into much of that, but if you are interested in distributed computing, we can talk offline after. It's actually really cool. We went from being like malware people to like distributed engineers, and it's actually really fun. So enough talk. We're gonna let Steve take on the demo stuff.
All right. So John was talking about the internals of the system and how we're structured. So I'm going to jump into our dashboard where it actually gives you the health of our system. That's a demo machine, of course. Like there's a red card because we have no ingestion right now going on. So at the top here, it's the middleman. So the ingestion goes through this guy. It prioritizes the file in critical, high, medium, low queues, and then it will feed the files through the system at a given pace so we don't overload the system. And if we get overloaded, that doesn't matter. If we send 10 million files to this and we can't process them and we fall behind, we'll start dropping files on the floor and just sample the files that we scan. And then here you got the dispatcher. Dispatcher is responsible to send to all the services. So it will actually look at the file type, do file class analysis on the type, and route it to the proper services for analysis. So if we have a PDF, it will only go to services that can process PDFs. And then at the bottom, you have each of the different services that you run right now in your cluster. You can see for each services, you have the number of workers per provisioned and the number of workers that are actually running. What that means is we can actually have a lot of workers provisioned, and then we could do distributed computing for those workers. And there's also the number of profiles referencing this service. That means that right now it's at 1, so that means there's only one box that can process that service. So ideally, you'd want to have multiple profiles that can run a given service. So if one box go down, you're okay, you can still process files, it'll just be slower. I'm talking about provisioning and profiles. To actually provision your cluster, it's actually really easy. You have a provisioning page where it shows you the number of cores that you have in your cluster and the amount of RAM that you have in your cluster. And then you can just pick the slider and say, okay, for the service, I want to allocate as much of this, like 12 APK, for example, and it'll tell you how many cores you need for it and RAM. It'll tell you if you're over-provisioned or not. So you can slide any of the services and get your provision running, and then you go at the bottom and you just say test provisioning plan, and we try to distribute those services accordingly in all the boxes that we have in the cluster, and then we'll apply those profiles to those different boxes. There's also a flex node parameter. Those nodes, instead of actually provisioning them and actually applying a profile that they'll have to run this set of predefined services, it will actually not run anything and just look at the queues of the different services. And the one that's the busiest, it will pick that queue, launch as much services as much instance of this services, and then try to get rid of that queue to get rid of the bottleneck. So when your system is unbalanced, that's like the one way that we found that we're just going to change the rules in the system so we can actually process those unbalanced workload. And then when you're done, when you've provisioned your cluster, you could just hit the host page where you have the list of all the hosts on your cluster, and you can just say, okay, you pick the nodes you want to restart, and then you just click the restart button, and it will load the new profile, and it will be provisioned as you asked for it. All right, enough about the infrastructure. Let's actually submit files to the system. So if I go to submit page, this is basically the landing page for AssemblyLine. You get there, you can submit files to the system. I'll get your attention to the sidebar here. It's where you can actually configure your scan. So if you look at this, you can configure priority. So if you have something that needs to get done now, you need to jump in front of everyone, you can set the priority higher, and then you'll get your file right away. It'll jump in front of everyone in the queues of the service and in the queues of the submissions that you do to the system. And then you have a time to live. This system is not a TKB. We cannot store all the data forever, and that's not the point. It's really just an in-out system. We put a file in, and then we scan it, give you a result, and then just take it out if you want to keep it, and put it in a TKB if you want. But we can't right now keep all the files because of the load that we get on the server for the hash index and everything. And then you have service-specific parameters that you can influence how the service will scan a file. So for example, we were talking about password-protected zips before. Let's say you put a really weird password on your file. You can actually just type in the password here, and then when we send the zip to the extracting service, it will actually use that password to extract the file. So these are parameters that you can send to the services to change their behavior. And then the last but not least, you have the service selection. So each service are categorized by category. And then you have an extraction service, networking service, static analysis service, dynamic analysis service. And then you can pick and choose the actual category or pick and choose the individual service. And then you just put your file in and you scan. So right now, I'll select all, and then put a file in, and then just hit scan. So file is scanning. You see the results coming back live, and then it's actually done. So I scanned the file in 4 seconds, from 9 to 13. So obviously, that's not the speed that you're going to get. What we do in the back end, we do a really high-level caching. So because I've submitted that file so many times to the system, it knows exactly what the results are, so it's just serving you the same results over and over. The service results are deterministic, so if you have the same hash with the same server's version, it will feed you the same results. When you view the submission detail, you have all your selection that you did at the beginning on that slide panel. So I put a password in for that zip. It didn't use that one because that zip was not encrypted, but yeah, so you have a password and you have the selection, how many days I want to have this file for, and all that stuff. There's a metadata section. Here I don't have any metadata for that submission, but if you were submitting the file through a really high volume ingester, you could put metadata so you can actually trace back that file to a given source or a protocol or whatever. And then there's an executive summary. While we're scanning those files, we're extracting features, which we call tags. And then these tags have a type and a value. For example, you have domain names, you have URI, you have AV virus name. So any tag that we extract, some of them will actually promote them to an executive summary. So analysts are able to make a good decision on which files they need to pursue. So for example, if I click on a Dooku sample here, I have an implant name which is Dooku, and then you see it highlights the file in my zip that's actually related to this. So I can actually drill down to those things. And if I click on any other thing, it will just highlight something else. So let's actually pursue this. So let's click on Dooku. Click on the file. You actually have the specifics of the file. So the hashes, the SSD hash, the size, the type that we've determined, and then you have the frequency. So the frequency is when we've seen it first, when we've seen it last, how many times we've seen this. And then you have a submission summary. So we're taking parts of the submission and try to get statistics about this. So here it's how many, which user submitted it and how many times. It's in min 12 times. And then the exhaustive list of generated tags. So all the features that we've extracted, they're all presented to you at the top. As you can see, I've clicked on Dooku on the previous page, and it's still highlighted, so I can actually follow through and see, okay, who did that? Who actually told me it was Dooku? So if I scroll down, you can see, oh, it's a Yara rule that we have for Dooku samples. That's the rule description, and then you see here the tags that we've generated because of that rule. So it's all good, but what else do I have on Dooku? So if I actually click the little search beside the Dooku tag, I could search the system for other instances of Dooku. Everything that we have in our database is fully indexed. So you can search on anything. We use Solar as a backend to do the searches. So that's kind of why we can't keep all the data. It's really hard for the system when you have millions of files coming in and you have to index all the files. So I can actually just remove, I don't want to search for only tags. I can actually search just for any instances of Dooku. So you can see I have results, I have signatures, and I have alerts. So if you want to know what that signature that I used to actually find the Dooku malware, you could actually click on it. And then you have the detail of that signature here in the system. So you get the full detail here. And we can even edit those signatures on the fly. You can click the edit signature. We built our kind of own standard to actually classify malware properly in our system. So for this test, that signature is a signature of group implant, so it actually detects implant. And then the name of it will be Dooku2, so if it actually hits on something, it will actually tag this malware as Dooku. And we have our own standard defined here in the malware standard, or if you go to help, you can see the Yara malware standard. So if you're interested in see which are the metadata fields that we've added to the Yara signatures to actually do all that classification and automatic scoring. Okay. Last week when we were at Hackfest, there was a presentation about APKs, and it actually gave me a really good idea to actually show you the power of AssemblyLine. So I'm going to submit an APK malware. and I'm going to actually tell the APK service to resubmit the dex file as a jar. So if I do this and I scan it, you can see here, I get the APK. I click on it. I can view all the generated tags. So we've extracted all the features for this thing so we can actually do our classification better. And then you'll go down in the system, go to the service that actually generated all those tags. You'll see all the things that we have to report on it. But then at the end, you'll actually see, okay, we've extracted a file. So the service created a new file and then resubmitted it to the system. It went through the whole process, and then this new file was processed by the system. If I click on that file, so that's now a jar file. So I took the dex of the Android malware and then created a jar out of it, and now I'm processing that jar. And now we have another service, which is called Espresso, that does jar file analysis. If I click on this one, you'll see that I have supplementary files. These are files that are not resent to the system for analysis, but that could help me to do my malware analysis at the end. If you go to the bottom, there's an audio recorder.java. If I actually view this file in the file viewer, and then here you have the source code for the implant that's already been processed, and we've extracted it, we've decompiled it, and brought it back as the source file. So that's the kind of thing that we try to do, so we can extract files from one binary and then resubmit it to the system and feed it to another service and actually get more data out of that service. So that's all good for one file with a single submission, but we've said that we're processing 10 millions of files per day. So how do we actually go through all that data? So we have an alert viewer where we generate alert to the system. Oh, just give me a sec. Data's too old. Is it all gone? Don't tell me it's gone. All right, so we have an alert viewer where we can view all the alerts for the system. These alerts will be classified in reverse order, so the newest alerts will show up on top. So the analyst, instead of actually just going through every single submissions in the system, they can actually just go to the alert view and see, okay, whatever we scored high and we think is malicious, and they can go through that data. They're grouped by MD5, well, by hash, so you can actually see campaigns. Like if you have one sample that was sent 100,000 times, you'll see one alert for that, the full 100,000 alerts, one card for that alert. And then you can actually process those in batch. You'll see all the details that we've extracted about this alert, and then we can actually categorize that alert. Okay, is that something that's malicious? Here we have something that we know is malicious. What's the priority of it? And then you can apply labels. So you can actually do a search query in Solr and say, okay, if anything matches this kind of file name with this regex, I can say, okay, it's campaign X, and then classify it and treat it as a bulk. And then you can actually take ownership of an alert. If I click on this one and say, okay, I want to take ownership of that alert. I don't want anyone else to process it. I just take ownership, and then done. Everyone else will say, okay, I'm processing this one. Applying those labels and those campaigns is really tedious if you try to actually go through and do it by hand. But what you can do is you can actually apply filters. So if you go to the workflow filter, you can predefine anything, any search query, and then apply and have the consequences about that defined search. So if I say, okay, if I find any size that's bigger than 1 meg, and I'll label it X large, and then all the alerts will now get an X large if they're bigger than 1 meg in the alert viewer. And that will be done automatically before they actually display to the user. And one more thing in the alert viewer, you can actually drill down by properties. So you can do statistics on the properties and say, oh, okay, out of these samples, I've attributed all these ones, and 7 of them are attributed to ATP28. I got 7 Ghost, 5 Dooku, and stuff like that. So you can actually say, okay, like I'm interested in APT28, I'll click on this, and these are the 7 samples for APT28 on that time range. All right. The other things I wanted to talk about here is the malware heuristics. So basically, we're extracting those features. We have a ton of checks that we're doing. We don't want people to redo those checks. And if they add new services, we don't want people to actually redo all the checks that we've built. So we've actually categorized all those checks into heuristics. So for example, in APK, if there's a duplicate permission definition, so there's a heuristic for this. So this is one of the checks that we do in our system. So we'll check if a permission is asked twice in the manifest. And if that's the case, that's not something that a normal developer would do, so we flag it. But that we're actually categorizing those checks so people know what we're looking for, so they don't have to rewrite the same things if they write new plugins. And last but not least, APIs. Everything that I did in the UI for this presentation could all be done through an API call. Everything is API based. We want automation as much as possible. You don't have to use our UI if you don't like it. You could just send a file in and get the results out and do something else in another interface. So everything you can do it through the APIs. We have a whole API documentation here. You can just click on whatever API call, and then you'll get all the details on how to use it and everything. All right. As I was saying, if you don't use our UI, you need to automate stuff. So, and John was talking about this. We do automatic defense on our data via APIs. So it's super simple. We package our software with a client, a Python client. So you could just install the client, run any Python interpreter, and then just import it, log in with your username and password, and then submit a file in and get the full results. You get a JSON blob. So it's really simple. We've built the client to be as simple as possible, so anyone can use it. And next, basically, writing a service is also extremely simple. You can write any service that do an external API call that runs a binary, or that actually are just in Python, and you can actually dissect the file in Python. But the idea is that you have one class that you need to overload, and then one method. It's the execute method. And then you'll get a request, and that request will contain a hash. And with that hash, you can actually go get the binary or query another source with a hash, or you'll get all the tasking as well, saying all the different parameters the service is sent to your the system is sent to your service. And then you can go from there. And you can actually also see all the tags that the previous services have generated for this file. So you can actually build a post service that will actually create results based on the results of other services. That's how we do the chaining, and that's why like the distributed computing is really pays off. Well, thank you. So I'll leave it back to John.
Okay, so a lot of you are probably asking, why are we here, right? We're CSE, we're super secret spies. Why are we actually talking in public? You know, we're all developers, we're all introverts. It's not because we like public speaking, I'll be honest with you. Not at all. To be honest, it's been apparent for quite a few years that we can't solve this problem ourselves, right? As much as we love government to just solve everything for us, it's not really going to happen, right? We've all kind of been suffering in silence. We're not really very good at working with each other. So we're trying something different. We're trying to come out and talk to people that are in this community. Because again, there's a lot of experts in this community that don't work for government. We're not the best at hiring everybody. And to be honest, shameless pitch, we are actually recruiting. So you know, I would literally hire everyone in this room. I can. My HR people would probably get annoyed with me, but that doesn't necessarily solve the problem, right? I take all the good security professionals here, and now there's no one else in the community, right? So we need to figure out a better way to get more people into this field, and what better way than to actually tell people what our problems are. So one of the questions we get a lot is why open source? And the answer I ask is why not, right? There's a better answer in that for me to go and partner with every single company in this room, with every single province, government, it involves lots of NDAs, lots of lawyers. Nobody really likes it. No one has fun. So this is our kind of a giving back to the community. We, as you saw in the talk, we use open source extensively for everything within AssemblyLine, as well as a lot of other our projects within the organization. we kind of had a little bit of an internal argument about how much to open source, right? So in this case, you'll see we're open sourcing the framework. We do have some services that have been released. We haven't released everything. That's one of the questions we get because, again, there's an arms race that always happens. It's a cat and mouse game. And I would argue right now that the mice are winning. So the other reason, this is, again, a quote from Scott Jones, as much fun as it is building automation and distributed queuing systems and all that stuff, at the end of the day, like I am a malware analyst. Most of you are probably in this field as well. I'd really like you to just actually do your jobs and do malware stuff, right? It's hard, I get it, but if we can get people to start focusing on the things that actually really matter, is how to detect a bad file, I think we'll get a lot better off. There are a bunch of tools that have been released within the last 6 months to a year, so they kind of scooped us on this. But we'd like to put another one into the community and see which one wins. This is another quote Steve pulled off the internet there. It's talking about this idea that we can't really keep stuff to ourselves anymore, right? So I have a really cool detection analytic. You have the exact same analytic. We're wasting our time, right? One of the stories I like to tell is working with a colleague in the UK. We both found this really cool sample years ago, and then we both spent about a month reversing it. Right? We didn't talk to each other because until we actually know what it is, we tend to not share. That seems to be the default within the community. And then the month finished up, we both wrote a report. We sent the report across, and it was literally a duplicate of each other. Right? So that's a month wasted of people that are really intelligent doing this work rather than just sharing things early, share often. Right? So that's kind of my pitch to you. If you get compromised, it's okay. It happens to the best of us. It's a lot better to talk about it and fix it early than it is to wait and kind of publish a report, and it doesn't really work. So when we released, one of the things we kind of made a mistake on is that we didn't really use the right word, right? So we said we were releasing AssemblyLine to the public, right? And for any of you who've even remotely involved in intelligence agencies and public relations, we have a little bit of work to do. The very first thing that kind of came up is, one of the comments was, "Oh, I'm not gonna install this CSE malware on my machine," which is cool because we're not CSEs, and you can install the CSE malware on your machine, right? It's not malware, really. It's not. People seem to be really confused that we wanted you to go take this home and install this on your desktop and use this as your AV and then send all the files to us. That's not what we're asking you to do, right? This was meant to be released to the public community, primarily people in the security community, so governments, large, small, medium businesses, certs, research labs, academia, InfoSec. If you're a single person working at home in a VM, cool, yeah, you can do it if you know what you're doing. But honestly, we're looking at people that have more established programs in this case. We would like to get more people in this community that actually understand what's going on. So if you're in academia and you want to talk, by all means, come and talk to us. If you're in corporate, by all means, we love to talk to companies. We can't protect everybody, so we're not going to try. We're just going to let you help you protect yourselves. So some links to the projects. One of the questions we also get is why Bitbucket? Why not, right? We have a GitHub repo. We have a Bitbucket repo. We're good with both. We have AssemblyLine separate from CART, so you can take a look at both. CART's actually quite small, really easy to read. We have bilingual readmes on everything, right? Government of Canada translation, yay. As well, we have a Google group for doing all of our interactions with the community. So if you are interested, pop in, ask some questions. Most of the craziness around the releases kind of died down, so we can actually have civilized conversations now. That's pretty much all we have. I'd just like to thank everyone for coming.